Hey guys, thanks for joining me today. We're going to be looking at Rock City Park in Olean, New York. It's just a couple hours south of Rochester, and it is a fun day to hang out there and at the surrounding Allegheny State Park. So, Rock City is definitely well known for its really cool rock formations, and which you probably are not surprised by. Lots of people, even though it says not to climb rocks, pretty much everyone climbs rocks here because there are these really narrow crevices, and there's really good, I'm not a rock climber, but handholds to be able to kind of pull yourself up through the sedimentary rock. You can see here with the layers where there's like abundant handholds that and I've seen students do this and they really enjoy it. They are, in some cases, very, very narrow cracks. You can see here in this rock layer, these are cross beds, which are created by sometimes in a river where you have like sort of slowing down currents, but there's definitely a strong current that produces them. Sometimes you see these in sand dunes, but this is more of a riverine environment that the rocks of Rock City are formed in. So the reason that you have these very tall exposures of rock with these very narrow cracks is because of a process called creep. So the rock layer here basically is what's called a conglomerate. We'll learn about that more on the next slide. But the conglomerate is a really strong rock layer. It is composed of quartz pebbles and it's cemented with quartz. Quartz is really resistant to weathering. But above and below this rock layer, there are very soft shales, and the shales will weather very easily. So what starts to, and then the whole region is sort of jointed and fractured. And so that's what creates these long, narrow cracks. Now, when the shale is when this stress that results in the jointing, when those cracks hit the shale, basically the shale just weathers away, and a process called soil creep occurs. Soil creep is basically when it's warm out during the day that rocks will expand, just like metals, because rocks are full of metals. So it'll expand during the day and then contract at night. And this cycle of expansion and contraction then also is a response to gravity. And so over very long periods of time, like decades, what will happen is the soil beneath this conglomerate layer will slide down slope. And when it does, it will carry the conglomerate layers right down slope as well. So this is also then, moisture definitely plays a role in here too. The blocks will eventually settle and rest on one another, and they will result in features such as these narrow, steep passageways, what people call streets, and sometimes they'll form caves, sort of like where you see these two here that are leaning up against each other. So the disorderly array of these conglomerate blocks initially misled geologists, and they initially classified them as glacial erratics or glacially transported boulders. But further study has shown that they're actually in place and they're slowly weathering out of place. And what happens is that surface moisture will get down into the joints. And a lot of times, especially in the southern tier of New York, you'll have repeated series of freezing and thawing cycles. So that'll cause rocks to expand and contract along these joints and widen and deepen the joints a little bit. Basically, weathering along the joints is what breaks these rocks into these very large blocks that you can see here in the picture, and then soil creep and gravity carries them down slope. It's a really cool spot though. And as you know, there's not a ton of places where rock is exposed right along the surface in New York State, so this is pretty cool. So the rock layer that is exposed is pictured here. Here's a rock hammer for scale. And then here's sort of a close-up. This rock layer is not in place because these are generally almost horizontally deposited, except where you see those cross beds that were in the last picture. This is called the Pottsville Formation. And the Pottsville Formation is a poorly sorted quartz pebble conglomerate. So these are all quartz pebbles. And it's a conglomerate because it's poorly sorted, rounded gravels that are cemented together. Now, the particular layer that we see in Rock City is a smaller part of the Pottsville Formation that's called the Olean conglomerate. And Rock City is, again, in Olean, New York. The Olean conglomerate it was deposited during a time period called the Pennsylvanian period, which is about 305 million years ago. It was deposited in a large river system. So there's lots of places where you can see that the pebbles in some cases are all sort of pointing in the same direction, which indicates a strong current. Again, we saw evidence for crossbeds, which in the last picture slide, which also indicates currents. And then you have series of places where basically here you have smaller particles that grade into larger particles here, which indicates that you have an increase in the velocity of the water moving in this area. So the uranium dating of some of the feldspar grains that are contained within the Pottsville Formation have been dated to 1.7 to 1.9 billion years ago. So the particles themselves are very old, right? 1.7 to 1.9 billion years ago. But the rock layer itself is 305 million years old. And that's because this material became cemented together in a large river system that existed during the Pennsylvanian period. So here is a paleogeographic map of North America during the late Pennsylvanian period. And you can see that New York is, I sort of traced out right here, but it is in this area right here. And you can see that there's a very large mountain range that we're going to talk about on the next slide. And we all know, right, we've learned about the Adirondacks, so here it's like an eroding feature. But what you see when you look in southern New York is a series of very large river systems that are basically draining some of the Adirondack Highlands, as well as this very large mountain range to the southeast. So that's cool. Let me go back. All right, the Pottsville Formation formed and in a river, but later, because of compressional forces, it became part of what's called a synclinorium. A synclinorium is a fantastic word. Oh, I should spell it out for you. Oh, it's right there. It's a regional scale syncline. So it has some smaller anticlines and synclines sort of superimposed within it, but a syncline is a downward arching fold that occurs because of ductile deformation, rocks basically behaving in a ductile manner. Erosion of the anticlinoriums, which you can see here, which are sort of the upfolded rocks. Erosion of the anticlinoriums uplifted during a time period called the Alleghenian orogeny, or a period of mountain building that occurred from about 350 to 300 million years ago, produced huge quantities of clastic sediment that was transported down by alluvial fans and high energy rivers like we see in the Pottsville Formation. Continued erosion of these anticlines will result in the seaward extension of alluvial fans and rivers, burying the quartz pebble-rich sediment. Cementation of these sediments subsequently resulted in the lithification of the Pottsville Formation. And this series of diagrams here on the right basically show you the Alleghenian orogeny. So if we start here during the late Devonian period, you can see that there is a large piece of land called the Avalon Terrain or Avalonia that formed onto North America right here. But you can see that Africa is coming over, and Africa collides during the Pennsylvanian period to form the supercontinent of Pangaea. And that is the picture that you saw, actually, that large mountain range on the last slide. Those big mountains were called the Allegheny Mountains, and they formed during the collision of Pangaea. So this is a recreation of Pangaea, and again, there you see New York. Here is Pangaea, and the Allegheny Mountains are the stretch of it in North America. This is actually a really cool website. You can put in your address and see where your address would be during the time of Pangaea, during the Pennsylvanian period. Okay, so the Olean conglomerate is a really cool rock layer. It actually outcrops in a few other locations nearby, including Allegheny State Park. There's a couple trails in Allegheny State Park called Little Rock City, Thunder Rocks, and Bear Caves, where you can also go and climb around on the rocks, as well as a few locations in Pennsylvania. Allegheny State Park is one of the largest state parks in the Northeast and the largest New York State parkland outside of the Adirondacks and Catskill Mountains. It's over 66,000 acres in area. And so here is Allegheny National Forest, and you can see Allegheny State Park right here, sort of between Randolph and Salamanca. It is the center of the only piece of New York that was not contacted by the ice of the last glaciation. 20,000 years ago, when the rest of what is now New York State was buried under a mile or so of ice, this area was ice-free. Today, the topography of Allegheny State Park tells us the story of how powerful the glacier was in forming the surrounding landscape. Areas to the north, northwest, northeast of the park, they are broad, flat valleys with steep-sided hills and flattened hilltops, molded by the force of the ice that rode over them and then melted in place to leave soils of glacial origin. The park, in contrast, has a sharper appearance with deeper incised V-shaped valleys, eroded by flowing water and not ice. These are called residual soils, meaning that they were formed outside of the glacier's influence and in place. The park's landscape, therefore, resembles the Pennsylvania's extensive and deeply incised Allegheny forest to the south. The park itself contains hundreds of inactive wells, the last of which was active in 1973. The oil wells were drilled down into the Pennsylvanian, Devonian, and Mississippian age sandstone and conglomerates. You can find some of these old natural gas wells throughout the park. All right, have a good time with your exploration.